Alright, this is section 7.5 part 2, and today we're focusing on objective 3. We're going to graph systems of inequalities, so we're going to graph more than one inequality. Now, to do this, we're going to have to be really careful with our graphing and how we shade, and also you might want to have some multiple colors that can be helpful here. Now, the way this is going to work is we're going to graph each inequality separately, and then we're going to see where the shading overlaps, and where the shading overlaps would be our final solution. Now let's look at this first example. The first graph is the one that we ended with yesterday, y is less than negative x squared plus 4. If you remember, that was an upside down parabola that was shifted up 4 units. So we'll go ahead and graph that. And it was a dashed line. So we'll go ahead and get that one dashed in. So this is that parabola from yesterday. And remember, when we tested the point 0, 0, we got 0 is less than 4, which was true. So we shade it inside the parabola. Now, in green, we'll graph this other one here, this line. We'll go up to 2 and put our y-intercept. Our slope is negative 3, so we'll go down 3 over 1. And up 3, and I'll go back 1. And we're going to graph it with a solid line because of the equals. It's a great line there. And now we're going to test the point. So we'll say 0, 0 again is the point we'll test. So we get 0 is less than or equal to 2, which is a true answer. So for the green, we're going to shade this way here. Now, each of those is graphed there. The final thing I'm going to do is I'm going to pick a different color, and I'm going to see where my shading overlaps. And I can see the spot where they're both shaded is along this parabola and all to the line. And then again, that parabola kind of is my stopping point. So highlighted in yellow would be the final solution to this system. So you can see we graph each one separately, and then we're going to color in the overlap. Let's look at another example here. Now, we have to be careful when we graph this one. Neither of these is in y equals form, so we're going to want to get them in y equals form to start. Let's start with number 1 here in blue. Now, I'm going to add a y to both sides. Actually, I'm going to do it a different way just to show you an extra step. I'm going to subtract an x from both sides. And then I'm going to divide by negative 1. Now, the reason I did it this way is I want you to remember if you divide an inequality by a negative, you have to flip the sign. So this actually becomes y is greater than x minus 1. We can graph that one now. We'll go over here to our graph. And we'll plot negative 1 is the y-intercept, and then our slope is 1. And this one's going to be a dashed line. We need to test a point now. We can test 0, 0. We get 0 is greater than negative 1, which is true. So we know that this is going to be shaded towards 0, 0. We're going to have to do the same thing here with equation number 2. So I'm going to start by subtracting a 2x from both sides. So we get negative 2x plus 12. And then divide by 3. So we get y is greater than or equal to negative 2/3 x plus 4. So we'll go ahead and graph that in green. I'm going to go up to 4 and put a dot, and my slope is negative 2/3. So we graph that line. It's going to be a solid line because of the equal to. And then we're going to have to test our point. Let's test 0, 0. And I'm going to get 0 is greater than or equal to 4. Now this is a false answer, so we're going to shade away from 0, 0. And you can see these become really helpful when we have multiple colors. And then remember, I'm going to grab the highlighter, and we're going to want to put the final solution where the two overlap. So we'll be above the green line and above the blue line, and that kind of gives us our overlapping region here. And so that would be the final solution. All the points inside there would work in both of those inequalities. Moving ahead, we now have an example with 3 equations. So we're going to get 3 equations on the graph. Let's go ahead and graph them one at a time. Let's start with the top one. We'll graph it in red. Remember, we need to solve for y. We need to get the y alone. I'm going to add y to both sides this time. Notice I don't have to flip my inequality and subtract 2. And so we get that one. We'll go down to negative 2. That's our y-intercept. And our slope is 1, 1. And we get a dashed line in there. And when we test 0, 0, we get negative 2 is less than 0. And that's a true answer. So the red one is going to be shaded above. Now, if we look at the next equation down, equation number 2, I'll graph in blue, you'll notice it says negative 2 is less than x, and x is greater than 4. So that's actually 2 different things. The first one is that negative 2 is less than or equal to x. Also, x is less than 4. Those are going to be 2 vertical lines. One at negative 2, and it'll be solid because of the equal to, and the other one's at 4, and it'll be dashed because it's just less than. Now, in order for both of those to work, x is in between there. So we're going to shade in between those 2 lines. The final one, y is less than 3. That's going to be in green. I'll graph that one. It's going to be a horizontal line at 3, and it's going to be dashed. We got a lot going on here. And it's all the y's smaller than 3. So if we test the point 0, when is 0 less than 3? That's true, so we're shading below. Now, a little harder to tell, but we need to look to see where all those colors overlap. And if you see, we're going to use this blue line as a border here, and the green dashed in the red. And so we're going to be in here. We have to be above the red, and we have to be inside that other blue line. And so we just get this little triangular region right in there. So we have to be below the green dashed line, in between the blue ones, and above the red. This is where we're going to end the video for today. Next time, we're going to take a look at solving application problems, word problems with these systems of inequalities.